Good afternoon. Good afternoon.
Good afternoon, sir.
Shall we start?
Yes, sir.
Okay. We'll solve the second problem on the composite section. The problem is like this. Let me write the sketch and come to know. This was asked in 2000 last year, I think, in one of the question paper. The load is 25 kilonewton. This is copper rod and this is steel rod. This is also copper rod. Lengths of the copper rod are 200 mm. Length of the steel rod length of the steel rod it's 250 mm. 250 mm. The problem definition is like this. A steel rod of length 250 mm and two copper rods of length 200 mm each are held together and support a load of 25 kilonewton as shown in figure. The cross-sectional area of the steel rod are the cross-sectional area of the steel rod are 800 mm square, right? Area of steel 800 mm square, and that of copper, area of copper is equal to 500 mm square. If the modulus of elasticity of steel is twice that of copper, modulus of elasticity of steel is twice as that of copper. Find the stresses induced in copper rod and steel rod. This is the problem statement. The approach is very simple. Since the the rigid plate of 25 kilonewton is a rigid body. It cannot undergo any deformation. This plate is rigid, it remains horizontal. Okay, it will not undergo any deformation. It cannot deform like this, one edge like this, other edge it will not deform like this. 25 kilonewton is a rigid plate. It will remain horizontal. For it to remain horizontal, therefore I can say deformation in copper should be equal to deformation in steel. Hope you can understand this, right? Are you able to understand this? Since the rigid plate, you can assume that two tubes upon which you have kept a weight. Since the plate is rigid, there is an equal deformation on both the tubes. You can assume like that. Okay. Now I can write PC LC by AC. DL is equal to PL by AE. PC LC by AC is equal to PS LS by AS. Yes. PC shall I write PC as sigma C into LC. Length of copper is 200. Young's modulus of copper is equal to sigma steel. Length of steel is 250. Young's modulus of steel is twice that of copper, right? It's 2 EC. Can cancel EC. I can write 400 sigma C is equal to 250 sigma S. Tell me the value in terms of sigma S. Therefore, sigma S is equal to
1.6, sir.
1.6. 1.6 what? 1.6 what? 1.
Newton per mm, sir.
No. 1. It will be Newton per mm square only. 1.6 times sigma C. Okay, but this is the compatibility condition. I'll call this as 1. I'll call this as 2. We know that load is shared in the composite section. Total load P is equal to load on copper plus load on steel plus okay, load on steel plus load on copper. So this rod shares some load, this rod shares some load, this rod shares some load. Total load is equal to summation of all the load shared by each rod. Or I can write P is equal to PS plus 2PC. Call this as 3. P is equal to PS plus 2PC. Total weight is 25 kilonewton, or let me write 25 into 10 power 3. Before that, sigma is equal to P by A, or sigma into A is equal to P. Sigma S into AS plus 2 times sigma C into PC. 25 into 10 power 3, which is equal to sigma S is how much? 1.6 sigma C.
1.6.
1.6 sigma C into area of steel. Area of steel is how much? 500. How much? Steel is 800 mm square. 800. Okay, you multiply it plus 2 times sigma C. Sorry, this has to be area of copper. 2 times sigma C into area of copper. It's 500 mm square. 500 mm square in 2 times sigma C. 2 times sigma C into 500. 1.6. Tell me in terms of what? Tell me the value of sigma C. much? How much?
10.96.
10.96
10.96. What is the unit?
Newton per mm
Newton
square.
per
Newton per mm square. We know that this I will call it as 4. We know that from 2 sigma s is equal to 1.6 sigma c. Therefore, sigma s is equal to 1.6 into 10 power 96. Sigma s is equal to how much?
17.536.
1.53 Newton per mm square. Okay, in case if you ask the deformation, you can calculate dl steel is equal to, and so on the same, dl copper or take copper pc lc by ac ec, which is equal to sigma c lc. Young's modulus we don't know, right? You should go for Young's modulus. You have to back substitute in this expression. You have to back substitute in this expression. What you can do? Okay. Okay, we know sigma, right? Okay. Okay, we'll try like this. We know sigma c. No, I require a Young's modulus c that we have to calculate by. Okay, I'll tell you. This can be done. Right now, it's not coming to my mind. Okay, this is about this problem. If Young's modulus is given, could have been directly calculated. You see, since it is not given, we can also calculate that. We have to substitute in this equation. What we can do, uh, sigma is equal to Young's modulus times epsilon. Young's modulus we don't know, sigma we know, epsilon I know dl. We can do that, but time being, I cannot do instantly. I will show in the next class. Okay, not to waste the time. Next problem will go. So, three cables or three rods are supporting. You can assume three rods are supporting a dead weight like this, a weight or a load like this, and from this end to this end, this end, it's 1 meter. From here, there is a weight of 60 kilonewton, and from this end to this end, it's 0.25 meter, and here it's 0.75 meter from here to here. Okay, understand this. Point 0.75 meter. Okay, the weight is not at the center, it is a some eccentricity, 0.25 meter from the center, the 0.25 meter from the center, it's 60 kilonewton. The problem statement is like this: a rigid bar is suspended from three rods and loaded as shown in figure. Rod 1 is of copper. This you will call it as rod 1, copper, with cross-sectional area of copper is equal to 100 mm square. Rod 2 is of steel. This is rod 2. This is of steel. And the area of cross section 150 mm square. And rod 3 is of aluminum. This is rod 3, aluminum. And the area of cross section aluminum is 200 mm square. 200 mm square. Determine the stresses in the rod. What are the stresses in the rod? Sigma copper is equal to how much? Sigma steel is equal to how much? Sigma aluminum is equal to how much? Take Young's modulus in rod 1, E copper if you say, or you can call it as A copper, or you can call it as A1, or this as A2, this as A3. Young's modulus in one material, this copper material, is 0.1 into 10 power 6 Newton per mm square, 0.1 into 10 power 6 Newton per mm square. Young's modulus in material 2, E2, it is equal to 0.2 into 10 power 6 Newton per mm square. Young's modulus in material 3, it is aluminum, it's 0.07 into 10 power 6 Newton per mm square. This is the problem statement. We need to find the stresses in copper, aluminum, and steel. It is nothing but sigma 1 is equal to how much? Sigma 2 is equal to how much? Sigma 3 is equal to how much? This is the problem statement. A load of, let me write the load properly, 60 kilonewton. It is acting downwards like this. Okay. Now, entire problem procedure is the same. Since this is the rigid plate, since the plate is rigid, it cannot undergo any deformation, that is, plate should remain horizontal. Therefore, deformation in one should be delta L of 1. Therefore, deformation in 1 should be same as deformation in 2, should be same as deformation in 3. Okay, let me write deformation in 1, that is copper, P1 L1 by A1 E1, which is equal to P1, I'll write it as sigma 1, L1 is 2000 mm, by A1 it's 100 mm square, into E1 it's 0.1 into 10 power 6. It's 0.1 into 10 power 6. delta L2 P2. Meanwhile, you calculate that A2 E2, which is equal to sigma 2 into length of 2. Length of 2 is 1500 mm, 1.5 meter. Area of cross section of 2, it's 150 mm square into E2, 0.2 into 10 power 6. Delta L3, which is equal to P3 L3 by A3 E3, which is equal to sigma 3 into length of 3, 2000 by area, it's 200 mm square, 200 into Young's modulus 0.07 into 10 power 6. Tell me all these values. Sigma 1, sigma 2, and sigma 3. Sorry, so I have done a mistake. Since I have taken sigma, area will not come into picture. My oversight, I have done that. What is delta L1 in terms of sigma 1? What is delta L1?
2 into 10 power 10 delta 1. I mean sigma 1.
No. It's sigma 1 into 2000 divided by 0.1 into 10 power 6. What is that value? Sigma 1 into 2000 divided by 0.1 into 10 power 6. What is that value?
0.02.
So 0.02 sigma 1, right?
Yes, sir.
Sigma 1. Tell me sigma in terms of sigma 2.
7.5 into 10 power minus 3.
7.5 into 10 power minus 3 sigma 2. This one. Two thousand divided by 0.07 into 10 power 6.
0.0285.
28.57 into 10 power minus 3.
How much?
28.57.
28.57 into 10 power minus 3. Right?
Yes, sir.
Thousand. Okay. 28.57 into 10 power minus 3 sigma 3. Okay. Give me a moment. Are you getting these values? Give me a moment. Right. Whatever the values what we got is right. Okay. Next, we'll go ahead. We know from first relationship, from 1 delta L1 is equal to delta L2 to delta L3, which means 0.02 sigma 1, 0.02 sigma 1 is equal to 7.5 into 10 power sigma 2 into 10 power minus 3 sigma 2, which is equal to 28.57 into 10 power minus 3. Or I will represent everything in terms of one term. Can I write 0.02 sigma 1 is equal to 7.5 into 10 power minus 3 sigma 2, or sigma 2 is equal to 0.02 sigma 1 divided by 7.5 into 10 power minus 3. Can you tell me what is sigma 2? This will call next section. What is sigma 2? It's 2.67 into sigma 1, right? Why you will take so long? 2.67 into sigma 1. I'll call this as 3. Next, I will use the expression, make use of the expression. I will take these two terms, 0.02. I will express everything in terms of sigma 1 is equal to 0.02 sigma 1 is equal to 28.57 into 10 power minus 3 sigma 3, or 0.02 sigma 1 by 28.57 into 10 power minus 3 is equal to sigma 3. Can you tell me what is sigma 3? What is sigma 3? Zero 0.7 sigma 1. 0.7 sigma 1. Next equation value. We know that total load is equal to load on member 1 plus load on member 2 plus load on member 3. Total load is shared by copper, steel and aluminum. Okay, let me write P is equal to P1 plus P2 plus P3. Total load is found to be 60 kilonewton. 60 into 10 power 3, which is equal to sigma is equal to P by A, or sigma into A is equal to P. Shall I write sigma 1 A1 plus sigma 2 A2 plus sigma 3 A3. 60 into 10 power 3, which is equal to, I am representing everything in terms of sigma 1 into A1. Area of cross section for the first member is found to be how much? It's equal to 100 mm square into 100 plus sigma 2. Sigma 2 is 2.67 sigma 1 into area of cross section of second member. Second member is found to be 150 mm square into 150 plus sigma 3 is found to be 0.7 sigma 1 into area of cross section of member 3 is found to be 200 mm square. 200 mm square. Can you tell me what is sigma 1? Now everything is in terms of one term. Can you tell me what is sigma 1? Is it audible? Can you tell me sigma 1?
Doing, sir.
Please tell me.
Mm. 428.57.
Check it out properly.
93.67.
93 point. How much?
67.
It's right. Why you are making mistakes? Calculation, you should not make mistakes. 93.67 Newton per mm square. I came to know. Now we'll substitute in these formulas. Sigma 1, which is equal to sigma 1, which is equal to 93.67 MPa. Sigma 2, which is equal to, from this previous relation, 2.67 times sigma 1, 2.67 times sigma 1, which is equal to 2.67 into 93.67. Now you tell me what is sigma 2. Sigma 3, which is equal to sigma 3, which is equal to 0.7 times sigma 1, 0.7 times sigma 1, which is equal to 0.7 into 93.767. Tell me what is sigma 3. MPa or Newton per mm square.
Sigma 2 equals to 250, sir.
Yes, 250.3. Sigma 3.
65.56.
65.56 Newton per mm
9.
square. These are the stresses induced in the three members: aluminum, steel, and copper. Okay, this is sometimes we'll ask for 10 marks. That's how simple this problems are. Next problem we will solve one more problem, and after that in Monday's class we'll solve another one typical problem and one easier problem. Next class after that on Tuesday we'll solve one more typical problem, and we'll finish off the first model. By Tuesday I should be able to easily complete the first model. Okay, any doubts you can ask me, you can mail me, you can ask in the Google Classroom also. Okay, I will stop at this point. Only 4 minutes remaining. I will be stopping at this point. Okay, thank you.
Thank you, sir.
Thank you, sir.